Okay, now let us have a recap on properties of reflection. Now look here, this is the image. I mean, no, this is the object. This is the reflecting um, line or the mirror, and this is the image. When I do it, I try to drag my image, there is no movement. But when I try to drag my object, the image also moves. Now, the characteristic or properties of reflection are these: that the distance between this image at any point to the corresponding, to the mirror, and then the corresponding distance from the same point in the image to the mirror are the same. So if I draw a line here, first of all, they are going to be perpendicular to this line of reflection here, and this line here, the distance from this point to this point will be equal to the distance from this point to this point. So as from here to here and here to here. So we talk about the corresponding points. This point corresponds to this point. This point here corresponds to this point. So the distance from here to here will be equal to the distance from here to here. All right? And as well, the distance from this point to here to the reflecting line will be the same as the distance from the object to the reflecting line. If I try to drag my object to the left that way, you see that the distance adjusts to be the same that way. If I try to change the shape of my object, the shape of the image also changes, and you'll find that what is here is what is seen there. If I try to change it that way, it also changes, and always the distance is the same. So this is a recap. Now you see, even this angle will be equal to this angle. This angle here will be the same to this angle. This angle here to the corresponding angle, and so forth and so on. So that way. So it is very, very important. When I move my object up, the image also moves. When I move this down, it also moves. Okay? But if I move this line this way, the image moves. But if I move it upward, without checking, nothing happens. All right? Nothing happens. Only the mirror is moving, but the image or object are not moving. If I move them without checking, if I move this line without checking like this, all right? So these are the characteristics I hope you could have come out with, that if I draw a line to the corresponding point, from the point to the of the object to the corresponding point of the image, it will cross at this line of reflection at 90 degrees here. It will cross at 90 degrees. Any line drawn will cross to the 90 degree. Any line drawn to its correspondence point. A point here, a point there. It will cross at this line of reflection at 90 degrees. So if I draw a line here to the corresponding point, which is here, it will cross here. I have to extend a bit. It will cross here at 90 degrees. Right. So hope I have made a good recap about the properties of reflection, properties of reflecting points. Here, mind you, we have points. This is a point reflected here. It is a point reflected there. This is a point reflected there. So if I draw a line here to that much, it will cross at 90 degrees. So I have made a recap of lines there, points, and figures, because we have a figure. I can change this figure to be any kind of figure I want, and you will see that I have the same figure in my other part. I have the same figure in the other part. So this is a good example of learning reflection. You see, if I change the appearance here, it will be the same to the other side. It will be the same. So I have the same. The lines are the same. The lines are the same. Okay. If I change it, can I change it from the mirror? If I change it to be this way, you see the lines are the same. Line map to a line, okay, and the angle maps to the angle. If I change it that way, okay, you see what happens. If I do that way, you see what happens there. The same thing happens in the other side. I change this side, the image also changes. The image also changes. Okay, change this side, the image also changes. And you see that line maps to a line, angle maps to another angle. Thank you for watching. Okay, now after having a very nice recap about the properties, now let us see how we reflect the points. How we reflect the points on x-axis. Our job here is to reflect all given points on x-axis. Now you can see here that I want to adjust this so that you can see it properly. You can see all points here. We have A, we have B, we have C, we have D, we have E, and we have F. All of these points are supposed to be reflected on this line here, x-axis. The line x-axis is our mirror. Right, now let us first of all write points, every point, and then we write its reflection. So these are points and we are going to have images. Okay, so the first point is A, which is 3, 2, as you see. X is 3, y is 2. Its reflection will be A dash, which is 3, -2. Reflection, when you reflect it here, if you reflect it to this, it is going to have 90 degrees here, right? It is going to show 90 degrees here, but at the same time it is going to have the same distance, 2 units to the reflecting line as the object had 2 units. So it's 2 units there and here, and then we have 90 degrees here. This line, if we draw it here, if this line is drawn the way you see here, if the line is drawn there, it is going to make 90 degrees. This line connects these 2 points. It makes 90 degrees here. Okay, so those are the characteristics or properties we passed through quickly. And so for every point, we are going to use the same formula when we reflect. Yeah? So we are going to see the second one. The second one is B, which is at -4, 1, and the image is going to be -4, -1. The image will be here, -4, -1, here, here. Number 3 is 2, 0. This is C, 2, 0, -2.0. X is -2, y is 0. There is no more movement in y. And we are reflecting on this line y equal to 0, or the line x-axis here. This is the line y equal to 0. Or it is the line x-axis, this line here. So see, there will be no movement. And let us see, the image is going to be C dash equal to -2, 0. It will remain there because there is no movement in x whatsoever. So it will remain there. D is -6, -3. D here. Where is our D here? -6, okay, -3 down, -6, -3. The image will be seen up here, 6, 3. Okay, so the image will be negative 6, 3. And then we have E, which is 0, 4. 0, negative 4. The image will be seen up here, which is 0, 4. Hope so. 0, 4. And the last one is 6, negative 2. 6, negative 2. That is F6, negative 2. And this will be seen at 6.2. It will be seen here, 6.2. So these are the points in the images. Now let us have a look when we reflect things. Now see, three values of x remained the same, but values of y changed. If they were positive, they changed it to negative, and if they were negative, they changed it to positive. For example, 4 here, negative, changed it to positive 4. 2, negative, change it to positive 2. 0 is 0. 1, change it to negative 1. Negative 2, change it to, 2 here, 2 here, change it to negative 2. So when we reflect a point, on x-axis, if you are reflecting any point on x-axis, the formula is that mx, this is a reflection in the line x-axis of point x, y, will give you x the same, so will be give you x, negative y, negative y. So this is the formula. This reflection in the line x-axis will give you the image. These are the point of the image here. So this is x dash equal to x, and this is y dash, which is equal to negative y of the original. Negative y of the origin. So this is the formula, and please make sure you put it into your mind. Okay, simple. And if you forget, you can do things like this, and you can remember. Very, very fast. You can remember that. Thank you for watching, and please subscribe for more videos.